Hey guys, Rev from Into Gaming. Um, Today I'm gonna run a quick video on the whole fixed PubG topic and some of the things that PubG or Bluehole is actually stating in their fixed PubG information. Um, the whole point of this is to run over this whole um, replication modulo modulus setup that they're using and trying to explain that for those of you that are a little confused with what I'm talking about is on the fixed PubG site, they're saying server performance down and they're saying improving server tick rate. Um, and they're basically putting it here black and white for us to read. When a player, when many players in close proximity at the start of a match or during the initial blue zones, the network replication server process slows down the server's tick rate. Now, this statement right here, just slowing down the tick rate, you can't modify tick rates once the game server is actually running. So when you initiate the executable to actually start the server, tick rate is constant. It doesn't change. So from a developer standpoint, this is driving me crazy. Um, so that's where I get into the replication modulus approach. Um, but anyway, they get into it and say replication refers to the process sending detailed information, position, state of items, doors, vehicles, and other characters between the PC and the server. Objects near your character need to be replicated as much as possible. This is true on every server check, which is even better if a game does that, a one-to-one. But other objects further away can replicate at a lower rate, 2 to 4 ticks, depending on the distance. We're planning on implementing a test fix early August and monitor tick rates, blah, 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 blah. Yada, yada, yada. Increase their experience, increase the tick rate, yeah, whatever. So let's look at it from this. If the tick rate cannot be modified once the server instance is running, then how do you go about modifying replication? Well, first of all, you have to understand what replication is, and we're going to get into it real quick. Just a quick, brief run through. Every actor, such as a pawn, this is a third person character, um, has a replication. It's an actor, it has replication values. And what this tells you is the network update frequency is how often per second this actor will be considered for replication, used to determine net update time. This is the max, so this is 60 hertz. If the server is running at 60 hertz, it's going to max out at 60 hertz. So that's the max replication rate, and that would be on a 60 hertz server with a 60 hertz net update frequency. That will be a 1-to-1 ratio. Every time the server ticks, you get a replication update for this character or this player if they are in relevant distance or have relevancy to you. So a player on the other side of a map, a large map, is not going to be relevant to you. So you might not get an update about that player because it's just pointless giving you the information. Now, the minimum update frequency is just what it says. You determine what rate to throttle down to when replicated properties are changing infrequently. So we have that. So when you get into modifying replication rates on runtime, you have to do things with the modulus. So basically, you count the ticks. So every tick, we're going to set the current tick count. We take the tick count variable, we increment the value. So we're going to add 1 to this variable. We're going to set it, and then we're going to take that new value and we're going to divide it by a number and run a modulus against it. And basically what modulus does is it returns the remainder value. So 3 goes into 3 one time, 0 remainder. So if the tick is 3 and you divide it by 3, there's going to be a 0 remainder. So on this instance, if the remainder is 0 every time when this runs, then the result will be true and we do something, otherwise it's false. So basically what we're looking at here with this 3 is we want to do something every third tick. So on a 60 hertz server, every third tick would be at a 20 hertz frequency. So in this example, replicating my character information to somebody, the max that this character would be replicated out to any other player if running this setup would be at a 20 hertz frequency. And I'm going to show you that with this little print string setup. So basically, when I run this, when I start the game, every tick's going to be printed out on the screen, but every third one's going to be different. And you'll see it real quick. It's going to be quick because we're running at 120 hertz. So every third tick, we're doing something. So that's basically what they're doing with the replication rates. They're tweaking them out like this. So you can do this at the beginning of an event, like the beginning of a round. You just set up a custom function or a variable, and if that variable is true, then you would run through this custom functionality. Otherwise, you just replicate normally. But let's say we wanted to do this do an update every 5 ticks, which would be, in this scenario, a 12 hertz update rate or replication rate. So every 5 ticks, we're doing something. Then I'm frame skipping now. Every time I hit this, it's just doing a tick. So hopefully this makes sense to you. Let me eject out of my character so you can actually see this guy move frame to frame. So that's basically what a character movement looks like in frame to frame. In Unreal Engine 4 at default 600 centimeters of velocity, full sprint. But anyway, ticks, modulation, that's it. So replication is set here, default in the player character, in the model, and the actors. So loot items would have a different replication rate or update frequency, min update frequency, and net priority. And you can modify that by using an expression like this. Take the current tick count on event, increment it, and then run a modulus and make sure that the result there equals 0. If it does, the condition is true, and so forth. So hopefully that explains what's going on with the replication rates over there on the fixed PubG setup.